everyone. Welcome to another podcast in our continuing series on the grid. Today, I'm delighted to introduce you all to Haroon Inam, who is the co-founder and CEO of DG Matrix, a really, really interesting company. You may have seen it on one of our webinars, but today we have the special opportunity to speak one-on-one with Haroon. Haroon, how are you?
Thank you very much. Very good. Very good. Appreciate the invite to the podcast.
Yeah, we're so excited today to have you with us. So maybe I'll start a little bit of background. How did you end up founding DG Matrix? Tell us a little bit about your background, kind of how you got here. Be interesting for our listeners to hear.
Well, I don't know if it's by accident or by luck, but I have found myself at the start of several waves of changes in the world. And one was, preceding the data centers. Another one was before solar came on board. Another one was before power electronics became prevalent on large passenger aircraft and military aircraft. And I had a chance to work on and contribute to each one of those changes. And we similarly saw a change coming with electrification. We did not see, neither did we anticipate the magnitude of the change coming with AI data centers, but we happened to have the right solution for behind the meter power aggregation. And that's what I think makes DG Matrix super interesting today.
Yeah. Timing is critical, isn't it? Sometimes you can have the right idea at the wrong time, but having the right idea at the right time you can't beat it.
I've had more than my shares of the right idea at the wrong time. That's for sure. Yeah.
Tell us a little bit about, how it meets up with today's grid. I mean, we hear about the legacy infrastructure that we have. It's been built out over many, many decades, but it's really struggling to keep up with the modern needs. And, kind of tell us a little bit about that, but how exactly does DG kind of slot in with something that kind of really addresses the current needs?
The global market, the grid market, right, was developed based on a centralized generation model. And the centralized generation model is where you might have one, two, or a multiplicity of generators spread in a region, connected by the transmission grid in sort of a meshed fashion, and then delivering power through substations to commercial, industrial, and residential loads. So power generally flows one way. And today, the problem is that AI data centers or AI factories are so concentrated in the demand for power that it's difficult for the grid to keep up without significant upgrades. And that's what's creating a need for a different model, a model where distributed generation behind the meter, distributed generation can augment the grid to power these loads. And it's not just data centers, it's also anywhere where large amounts of electrification is required for buildings or fleets of vehicles. It's just that AI data center power is very, very concentrated in demand right now and a massive uptick.
Right. And I guess it's fair to say that while, a lot of the focus in AI and on that race has been around the chips, but actually equally it's around the access to energy, in terms of winning that superhuman intelligence race, as some people call it.
Yeah, that's right. It's a race to the next level of intelligence for all of us. And power is the limit today. It's not the GPUs or the chips. It's not the software that's behind those chips. It's actually power availability, and that's why our solution becomes more critical.
And in a nutshell, how would you describe your solution to sort of the regular, non-technically minded person? What would you, in a short form, describe what DG Matrix offers?
DG Matrix offers a very simple solution compared to legacy solutions for blending multiple forms of power behind the meter, or for that matter, in front of the meter with the grid power. So you can combine grid power, AC or DC power, batteries, solar, natural gas gensets, turbines, fuel cells, all of it in one device, and then deliver AC or DC power simultaneously to data centers. That's what our device does. Never has there been a device like this in the market before.
Well, one is used to seeing many of these diagrams with so many different pieces in it, 15, 20 different components. And I think I've seen one of yours where it's you cut out more than two-thirds of them. I mean, that simplifies things.
Yeah, it was the vision was sounded really good when we started, but getting it to work was a heck of an effort, and it took us over 1 million engineering hours to get to a point where we're shipping units today. And inventing that technology and all the disciplines that go into it was a significant challenge. And today it's a huge barrier to entry for others.
Yeah.
But yeah, we do eliminate a lot of different pieces of equipment, and that gives us a massive cost advantage as well.
And the kind of sort of future proof, it's really that you can design your system really through the software, not necessarily the way it used to be, through the hardware architecture, right?
That's right. One is that at the very fundamental level, in billions of seconds, we can reprogram the machine to have very different characteristics, the same machine. So that allows you to have the same spare parts for a multiplicity of applications, whether you're powering up supermarkets or you're powering up a gang of EV chargers or you're powering up AI data centers, the most massive market. It's the same product. It's designed through firmware. However, we have gone a couple of steps beyond that, and we're developing software that allows our units to create a power fabric inside a data center, where any form of distributed energy and grid energy can be rerouted to the racks that need it the most. And that software provides a very compelling advantage to use every watt to generate tokens.
Yeah.
Tokens are how AI is measured. And so our goal is to allow the cheapest form of tokens to do power availability.
I guess would an analogy like with Tesla be apt, where you buy the car, but there's constant software updates, and which makes the capabilities of that vehicle constantly up to date and fresh. So you don't have to replace the car; you just need to keep updating the software. Where hence with the solid state transformers, if you will, um, they're future proof in that sense.
Yes, there is a considerable amount of future proofing through regular, I would call it regular and controlled firmware and software updates. But yes, that's built in. So we can add multiplicity of features to allow folks to stay at the front of the latest offering, eliminating stranded power, offering better efficiency, and offering better costs.
So how is this kind of competitive edge that you've got? How's that transformed into some of your commercial progress? What are some of your better known big projects around the world?
Well, so a lot of the demand is concentrated in the United States for AI factories. AI data centers, and the reason we call them factories is it's NVIDIA's advice, is that data center has always been considered a cost center, but a factory generates money for you. And so their preference is to use the phrase AI factories. And that's why we call them AI factories. But yeah, the demand is very concentrated in the United States, and we are a younger company. We're not a 50-year-old incumbent with global operations yet. So there is always a little bit of scrutiny we have to go through for some of the orders. But today, we are sitting on a commercial pipeline through 2029 of over $14 billion. And we're looking at $350 plus million of verbal purchase orders for delivery next year. And some are crossing the line to be formal ones. So we're scaling up significantly over the next 2-3 years to deliver large scale orders.
Wow, that's a massive growth rate.
It is a massive growth rate. What we have to do, quite frankly, is make sure that the quality and reliability of the product is preserved. we've done a lot of work for 3 years in defining the reliability as well as the quality. But we have to make sure the supplier quality chain is well vetted, and we have our production testing systems placed at the suppliers to ensure that whatever ships to us does not deviate from our critical to quality metrics.
Well, that's wonderful to hear. In terms of moving a bit more to the grid, where do you see the opportunities emerging and what are the trends driving them? For example, earlier on, you were mentioning about the increasing role of power with data centers. And on some of our prior calls, you had an interesting insight of saying that power is acting as a limiting factor for superhuman intelligence in terms of what you can do to actually shorten the time to generation so that these data centers can actually get their power faster and actually, get their skates on.
So I think first of all, there's a six set of criteria we look at to see which data centers are really going to go in, and it's power, land, permitting, not necessarily in any order: power, land, permitting, and then fiber, offtake, and financing. So all six need to be in place in order to see that the data center moves forward with construction. We found one more thing, that when experienced people and teams are putting in data centers, there's very little movement from the initial plans. But there's a lot of new folks trying to get in, and that's where there's a lot of movement because they haven't done something this complex before. So in that, where we come to help is we come to help on the power side, especially if there's natural gas available to allow behind the meter power generation. And most of that is concentrated between Texas all the way up from the southeast United States to Pennsylvania. That's where the natural gas is available the most. And a large amount of data centers are going in Texas. So that's how we screen for where we can help the most consolidation of data center power.
Interesting. I guess another aspect as well is you were mentioning on the natural gas, but as you get more and more renewables in the grid as well, it's also causing the grid to become more volatile instead of, having natural gas where you could easily turn the power on and off, less issues with inertia. You're actually having to deal with a much more volatile grid in real time. So maybe talk, if we can discuss a bit about, how DG actually helps address that as well.
Sure. So because we have a device called a multiple port solid state transformer, each port connected to a different energy source, we can mitigate the fluctuations, the typical fluctuations in solar as well as in wind through the creative usage of both long duration batteries, short duration batteries, and supercapacitors. Supercapacitors are great for sub-second transients. Batteries are great for seconds to minutes, and then long duration batteries are good for hours and days. So our technology allows the merger of all three. However, I'd like to say that we don't see a lot of data centers getting powered by wind just because of the very nature of wind power today. It's not that prevalent in steady form across the country. And then solar does have that the daily cycle, forcing you to have large amounts of batteries. In addition, solar requires a lot of land. So for generating a megawatt, you might need 120,000 square feet of solar cells and concomitant equipment. So we don't see solar taking off as much unless it's in the Southwest United States where there's considerable land available and cost-effective land available.
Makes a lot of sense. And I guess when would you say that the market actually has overlooked and needs to change in terms of, you were mentioning that you're making incredible progress with data centers, you got this big pipeline. But what do you think the market overall has overlooked, in terms of their segments that really should receive more of a spotlight that clients are overlooking?
So one way that our solution helps the grid is by having distributed generation aggregated over a large area. So let's say you look at the city of Atlanta, and you say, hey, I can identify 500 locations around the city where I could put in 10 megawatts of power. up to 10 megawatts of power, then that's a large number of units to aggregate. That's multi-gigawatt capacity. And you could use that capacity to power up data centers. You could use that capacity to shave the peak that the grid needs to supply, typically between 4 p.m. and 8 p.m., especially in Atlanta on hot summer days. So that's a massive change, because if you can do a few hundred of these units in under a year, you could add multi-gigawatt capacity in under a year. The concentration of AI data center demand is causing companies to invest billions and billions of dollars in getting that timeline to deploy these large amounts of aggregated distributed generation models very fast. So that's the way we can help the most. On the other hand, I think another way we help is by not requiring grid permitting. We are not AC coupled to the grid. We just take a grid input, and that takes all the interconnection studies out. So rather than have a 2-year plus wait for an interconnection study, we can typically get permitting in a handful of weeks, because we do not need export to the grid, nor do we need a grid interconnection. Now, having said that, I think the transmission and distribution networks do need a massive amount of capital investment, and the utilities are gearing up to do it. And so over the next 5, 7, 10 years, we think there will be a lot of capital flowing into grid upgrades as well.
Makes a lot of sense. And what do you think would then be key challenges for a market to overcome more broadly? Like if you had a wish list where, you could have 1 or 2 things solved overnight, what would really help the most?
I think what would help the most is if utilities got behind distributed generation, or actually owning distributed generation, it would be a huge uptick in electric power availability, rather than just follow the centralized generation model. Now, centralized generation model is very reliable, and that's what the whole grid has been set up for 50, 80 years. So you can't expect them to change and just jump to a distributed model, and I don't think that's realistic. But what's more realistic is that utilities use their large field service fleets and their large capability to absorb power to get behind distributed generation and make it part of their operating model.
Makes a lot of sense. Very good. And I guess maybe shifting on to your growth plans.
Well, our growth plans are, we have just signed a significant lease on a factory that gives us multi-gigawatt production capacity in 2027. We're signing leases on other factories, as well as with 2 very large multi-billion-dollar global contract manufacturers, to get up to 1 million square foot each from them, starting second half of 2027. That's how large this demand uptick is for us. So factory space, factory workers will be a big focus in the next 12 to 18 months. In addition, we're hiring a number of supplier quality engineers to make sure that we help the suppliers vet their chains and ensure a consistent quality and reliability of the product.
Does the U.S. continue to be in the near term as well your main market, or are you also growing globally at this point?
The demand in the U.S. is so concentrated and so massive for AI data centers. That's where we have the most focus. Not only because it'll be easier for us to support it here, we're signing deals with integrators and soon to be announced with large electrification conglomerates, where we have access to hundreds to thousands of field service engineers with very simple training packages. So let's get it right in the U.S. and then we're looking at significant demand coming from multiple other areas, including Europe, some demand from Australia, Japan, Korea, but the concentration in the U.S. is so much that I think we can easily cross $1 billion of revenue just by serving the U.S. market in the initial couple of years. 2-3 years.
That's impressive. And also you reference your growth in numbers of people. I understand in Pakistan you're planning to grow your R&D center quite considerably.
Yeah, we have about 450 people today. 75 of these people are assembly people. They're machinists, very skilled and trained machinists. They're test technicians, and then the other people, more than 350 people, are engineers. About a third have master's degrees. There are 20 to 25 PhDs, and that gives us a significant footprint. The labs, the offices, and the factories in all of our videos, people frequently comment it looks like a Silicon Valley set of offices, and that's how we've set up there. And we look at possibly doubling over the next 12 to 18 months there. But we're also adding a huge number of engineers and people in Raleigh, North Carolina, in the next
Yeah.
12 to 18 months as well.
Yeah. Yeah. And as you grow, I mean, I understand your margins as a business are actually higher than the industry norm. Tell us a little bit about that, Haroon.
I don't know how many people will be seeing this podcast, so I'm unable to comment on what the margins would be, but I can comment on this. We promise a very decent capex reduction to data centers, and so it's a big advantage for them. We also offer massive advantages above that capex reduction in eliminating stranded power and in offering far smaller footprints, and soon to come a far faster way to commission the product, leading you to faster compute revenue. With all these benefits, we're still promising a capex reduction, but you have to look at the benefits that we're bringing. If we happen to make a decent margin, well, isn't that the basis of capitalism?
It is, and I think, look, as you look at your growth plans going forward, the we see that from the financial sector, we see good margins as a way to kind of help fuel that growth. But I also, you did a less than a year ago, you did a significant raise of 60 million, which was really well received. And I understand you may need to do something in the next year or so, or tell us, are you able to tell us a little bit about your plans?
Sure. Excellent question. I think we did a $60 million raise led by Engine Ventures. We closed that in February. While we're sitting on substantial cash, we are looking at an expedited raise in the 150 to $200 million range within the next 12 months. The timing depends upon the number and amount of the dollar amount of POs that cross the line with deposits. But it could be reasonably soon, but we think that's going to happen within a year.
Right. And that's really off of the back of growth domestically in the US.
It really is. The fact that we have very large companies looking at carrying this product internationally, looking at carrying actually several of our products internationally. We want to expand there as well. But the plans that I'm sharing today,
Yeah.
including this raise, are almost all 99% based on the USA.
Yeah, no, I think I'd agree, but I will say I think what the good work you're doing there will be noticed by players in Europe and Asia, because they have similar issues. You know, these perfect storms around capacity or transformers and data centers. So I think there may be a lot of benefit they could get from working together with you.
I think there's already quite a bit of interest coming from the areas I mentioned. We just have to focus on where we have the most demand for the least amount of we got to stay focused on exactly where the most demand is coming from for now.
Absolutely. Thank you.
Thank you very much. Thank you.